Hey everyone, today I'm going to show you how to make a Slayer exciter. In the first part of the video I'm going to show you how to make it, and then I'll show you how it works. So let's get to it. To make it, you'll need the following things: a 22 kilo ohm resistor, a NPN transistor, red or green LED, 9V battery and clip. You'll also need 26 to 32 gauge copper wire, a plastic tube, some thick insulated wire, and a breadboard. So here's the schematic of the circuit. The credit for the schematic goes to Ludex Science. Take a plastic tube that's about 1.5 inch in diameter and then poke a hole at the end of it. Pass the wire through it and apply tape to keep it in place. Then start winding the wire around it. You can coil the wire about 275 to 325 or 350 turns. After every 50 turns, I decide to use nail polish to keep it in place. Also try to make the coils as neat as possible. So try not to overlap any coil. So this is the hardest part of the process because it takes the longest. So just try to be patient with your winding. When you're done with the winding, poke another hole at the end and pass the wire through it, and use nail polish to keep the wire in place. Now, using the scissors or X-Acto knife or sandpaper, remove the insulation from the ends of the wire. This is a really crucial step, otherwise you're not going to be able to make contact with the wires. So this is going to be our primary coil. Now refer to the schematic to build the circuit on the breadboard. First, I started by placing the transistor in the middle of the breadboard. Then I attached the resistor to the base of the transistor. Then I attached the negative side of the LED to the base of the transistor. I attached a jumper wire from the emitter of the transistor connecting to the positive side of the LED. Now I connected the positive end of the battery clip to the resistor and negative end of the battery clip to the LED. Connect one of the ends of the primary coil to the positive side of the battery and the other end to the collector of the transistor. Now connect one of the ends from the secondary coil to the base of the transistor. Now you could place the circuit on a platform of your choice. You could also use a cover. I took a ball and wrapped aluminum foil around it. I put the ball on top of the circuit and I attached the wire from the secondary coil that was not connected to anything to the ball, and then I glued it onto the top of the coil. I attached the battery, and now when you bring a CFL light bulb close to it, it should light up. And also if the transistor gets too hot or if it starts to smoke, just take off the battery immediately. So there you have it, it works. So let's talk about the circuit for a while. So this is an LED where the longer side is the positive side and the smaller side is the negative side. The symbol for an LED looks like a diode. So the side with the arrow is positive and the side with the line is negative. And this is the diagram for a transistor. We'll be using an NPN transistor where the emitter is the left pin, the base is the middle pin, and the collector is the third pin. So this is how the schematic symbol looks for a transistor. So here we have a transistor in a circuit connected to the battery. A transistor is similar to a switch. When a positive voltage is applied to the base of the transistor, the resistance between the collector and the emitter of the transistor drops from its maximum state. So only when there's a positive voltage being applied to the base of the transistor can current flow through the transistor. So right now there is no connection being made to the base of the transistor, so no current flows through the collector of the transistor because the resistance of the transistor is too high. Now we have a resistor connecting the base of the transistor to the positive side. Now a small amount of current can flow through the resistor to the base of the transistor through the emitter down to the negative side of the battery. It transfers the resistance between the collector and the emitter from maximum to lower. So now current can pass through the collector and the emitter of the transistor to the negative side of the battery. So now we added a load to the circuit, so we added a coil in between the collector and the positive side of the battery. So just like before, current flows to the base of the transistor down to the negative side of the battery. Current again flows through the coil to the collector and the emitter to the negative side of the battery. When current flows through a coil, it produces a magnetic field. So this is what we have so far. We have a magnetic field being produced in the coil. Now we connected a secondary coil to the base of the transistor, and we connected a diode from the base of the transistor to the battery. What happens is when the primary coil produces a magnetic field, it induces a current in the secondary coil, which is in the opposite direction of the current flowing through primary coil. So in simple word, it creates a vacuum of charge over here in the secondary coil. So the current that's flowing through the collector and emitter gets pulled over through the diode to the secondary coil to fill that vacuum. Also, some of the current that's flowing to the resistor gets sucked up through the line to the secondary coil. Electricity tends to follow the shortest path, so the path with the least resistance. So over here you have a big resistance that's about 22 kilo ohms. So instead of taking this path, the electricity rather takes the path through the collector and the emitter through the LED to go to the secondary coil. So less and less current goes to the base of the transistor. So at a point there's not enough current at the base of the transistor, so current stops flowing from the collector and emitter because the resistance of the transistor becomes too high for the current to overcome. When that happens, the magnetic field of coil 1 or primary coil drops, and when you have no magnetic field at primary coil, you don't have a voltage being induced in the secondary coil. So there's no more vacuum in the secondary coil that needs to be filled up. So over time, this flow of current also vanishes. So now we're back to square one. Again, current flows through base. The resistance of the collector and emitter drops. Current flows through the coil down to the negative side of the battery. The coil produces a magnetic field again, which in turn causes a current to flow through the secondary coil, produces a vacuum, which causes current to flow up to the secondary coil. And this process repeats over time. So it creates a really fast oscillating voltage. And since the primary coil only has 5 turns and the secondary coil has 275 turns, like a transformer, it amplifies or steps up the voltage on the other side. So if you have 9 volts on this side, 9V on this side, it steps it up about 60 times, so up to 540 volts or more. Okay, so you might be wondering how the secondary coil is not connected to anything but current still flows through it. In this circuit, there's a parasitic capacitance between the coil's top and the ground. It's also called a straight capacitance because it's not intentional, it's just there, you cannot control it. Since there's a capacitance between the ground and the coil, current can flow through it. So just because the secondary coil is not connected to anything, it doesn't mean current is not going to flow through the coil. So as we said before, we have a really high voltage on this side, really high voltage, so let's just represent that with that. So when you bring a CFL bulb close to the circuit, what happens is that high voltage, or the electrons, jumps through the air to the elements in the CFL bulb and goes to the ground. This excites the elements in the CFL bulb and it produces a light. So that's how the CFL bulb lights up whenever you bring the Slayer exciter circuit near it. So one problem you might be having with the circuit is that the transistor gets too hot, and that's really normal. I had the same problem. The thing is, these type of transistors are not made to handle a lot of current. So what you could do is you could attach a second transistor in parallel to the one that you have already here. So all I'm doing is I'm connecting the pins same as before with the transistor. What it does is that it divides the current between the two transistors, so instead of one doing all the work, they both share the same heat and also share same current, so it doesn't heat up that much. And you could also try changing the resistance of this resistor to limit the current flowing to the base of transistor to keep it cool. You could also attach a heatsink to this transistor, or you could use a transistor that's made to be used with high currents. So this is a really simple explanation of how the circuit works. I'm not really good with electronics, so I'm not sure about the details of how each of the components contributes to the circuit. If you find any mistakes in my explanation, I'll be glad if you point it out to me. Thanks a lot for watching this video. If you found this video useful, leave a like, comment, and subscribe to my channel for more useful videos like this. If you find any mistakes in the video, let me know in the comment section below. See you in